All right, web assigned 6-4, number 7. You've got a disc, big R, and you've got an attached pulley of small r. I believe in the problem it says that the small r pulley is very little mass, so we're not going to include its mass in the moment of inertia of the disc. So they give you a motor and some motors generating this thing, giving a clockwise spin. They give you the acceleration of the spin. They give you the tension in the upper part of the cable. That's given. They give you the mass. So they give you everything you need to know. And then the goal is to find the tension in the lower part of the cord. Giving up that lie we told you, right, that the tension in a cord or a string is the same everywhere. That's not true once the spinning object has mass and inertia. So you're going to have different tensions on different sides of the small pulley. Otherwise it wouldn't accelerate, right? We need a net torque in order to get the disc to accelerate. So if these torques were the same, because the tensions are the same, acting at the same radius, we'd have a net torque of 0, and the disc would not physically be able to accelerate. So there has to be a difference between the upper tension and the lower tension in the cord. So this one's pretty straightforward. Sum of torques equals moment of inertia times acceleration. We're going to model this as a disk, so the moment of inertia is 1/2 mr squared. The torques then are clockwise, we're going to call positive, since that was the given direction of the acceleration. That's the most convenient. So the upper tension is causing a positive torque, where the lower tension is causing a negative torque, trying to rotate it counterclockwise. That's basic setup. Algebra, solve for tension in the lower cord. All the numbers are given. You have the tension, you have the radii, you have the mass, and the acceleration. So that one should be it. There's a part B, which asks, what if the tension in the cord or the arrangement of the motor and the pulley are arranged such that the tension in the lower cord goes to 0, but the tension in the upper part of the cord remains the same? What will the new acceleration be? So if there's no tension from the lower part of the cord, then the only torque is due to the upper cable or the upper cord. So that's the net torque times the little r, and then 1/2 mr squared for the moment of inertia again. Solve for acceleration. That's that one.